Okay, back again. Now remember what I mentioned earlier on. I mentioned that at this point over here, we drew the effective room sensible heat factor line, effective room sensible heat factor line, from the point 0.75, which is what we determined for our effective room sensible heat factor, and we drew it through the point 2 that we'd given in the example, and that point was at 24 degrees Celsius and 50% relative humidity, that point over there. There it goes. Now, when you get an example given to you in the exam or test where it says that the internal conditions or the room conditions have got to be 24 degrees and 50% relative humidity, then you know you're going to smile, because it's as simple as what we've done over here now. But what happens when the internal conditions are different? So let's have a look at one. And obviously I'm not going to do the I'm not going to do the rigor of doing all the calculations again, because the calculations remain exactly the same. But the only thing that is going to alter is the following. So let's take a value again of effective room sensible heat factor of 0.75, say, for argument's sake. And we got an internal room condition of 22 degrees Celsius and 40% relative humidity. Now, remember I spoke about the swivel point or the comfort zone. The comfort zone, I've still got it indicated over here. There I've got it at 24 degrees Celsius dry bulb and 50% relative humidity. And that is a swivel point. That's the point that you line up between there and 0.75 over here on this side. Or if your effective room sensible heat is 0.7, you'll be over there. If it's 0.65, it'll be over there. But that is a point that's the hinge that this whole thing works about. So let's say that our outside temperatures is 33 degrees Celsius and 33 degrees Celsius dry bulb, 31, 32, 33, and 25 degrees Celsius wet bulb. That's state point number 1 over there. And that state point 2 is at 22 degrees and 40% relative humidity. And 40% relative humidity. Oh, wait a minute, I'm going to change it to 50% relative humidity. Okay, 22 and 50% relative humidity. 22 and 50% relative humidity. So in other words, that is where state point 2 is going to be over there. So when we draw a line between the two of them, it comes in over there like that. Now, I said that the sensible heat factor was 0.75, and in the previous one, our internal conditions were 24 degrees and 50, which is exactly on that swivel point. This one over here is at 22 and 50%. So now this is the way we go about doing this one. From the swivel point, do 0.75 over there. We draw a line. I'm going to just draw it in red over there so you can see it nice and clearly. That is between 0.75 over there and the swivel point of 24 degrees Celsius and 50% relative humidity. But now remember, in the previous one, we drew a line from state point 2 to the saturation line over there. But now we've got to do exactly the same thing over here, but only starting at 22 degrees Celsius and 50% relative humidity. The way we do it is we draw another line that is parallel to that line that you've just drawn. Now, that line over there, always try and draw it as long as possible, because the longer the line is, the more accurate you're going to find that you can do this next line. What I sometimes do, and what might be an idea for you fellows, is to get yourself a compass. Now you don't have to, because if you're very confident at being able to draw this thing spot on, then you won't have too much of a problem. But what I do, if I want to be nice and accurate on this thing, I take a compass and I set it the distance from the state point 2 to that line over there. Okay, so there I've got all I had. From state point 2 up onto that line, I will rats, if that does that one more time, I'm going to have a fit. I just draw an arc. Then, at perhaps one of the extremities of that line, I draw another arc over there. And I then join up, and I'll draw this one in black, from that second point, state point 2, to that arc. So in other words, what I've essentially done is I've ensured a parallel line by having, I know what that distance is, and by doing another arc over there, which is the same distance from that red line as what that statement is, I can ensure that line is then going to be running as close to parallel to that effective room sensible heat factor line as possible. And there I go and draw it. So now what happens is that when I want to determine what is my apparatus dew point, where that line, and remember the line that we are interested in, the one that determines our apparatus dew point, is the one that is projected from state point 2 to the saturation line, okay? And in the previous one, we basically just had that red line, which was from 0.75 through 24 and 50 degrees, and we read off our apparatus dew point over there. This one over here, because of the fact that the state point 2 is now lower in temperature lower in sensible temperature than the swivel point, which is now, this one is 22 degrees and 50%. We draw from that point to the saturation line over there, and we then go about determining, I encourage you guys to draw things accurately and straight, and yeah, I'm just falling in the trap myself. And then you determine your apparatus dew point that line. Okay, so let me just go through it again. When you've got an example that they say that the internal or the room conditioned values are 24 degrees and 50% relative humidity, you basically sit back and relax, because you don't have to do the second line, because you know whatever you've determined in your sensible heat factor on this side over here, you're just going to draw it straight through the 24 degrees and 50% relative humidity, which represents, in the example's case, would represent the room condition, but at the same time it also represents the approved comfort position for air conditioning, which is 24 degrees and 50% relative humidity. You just draw it straight away through, and you pick up the apparatus dew point over there. When your room conditions, like I've got over here, is not 24 degrees Celsius, because room conditions, or the comfort zone, is 24 degrees Celsius, dry bulb, and 50% relative humidity. In this particular case, it is 22 degrees Celsius and 50% relative humidity. And we find over here that we've then got to, we are that amount of distance off of the comfort zone. There's the comfort zone over there. If you get one of a psychrometric chart in an exam or in a test, okay, and that little swivel point has not been indicated on it, because sometimes it's nice, you find that they'll put a little dot and a circle around it just to indicate it. If it's not given, make sure that you indicate it yourself. At 24 degrees Celsius and 50% relative humidity, you put a dot and you put a circle around it. That is if you've got a psychrometric chart that does not have that indicated. You will indicate it yourself, just to focus yourself on it, okay? You'll do the rigmarole in terms of the calculations to determine what is your sensible heat factor, your effective room sensible heat factor, and then you're going to draw a line from the effective room sensible heat factor, which in this particular case is the red line, through that swivel point that you would have put on your psychrometric chart if it was not supplied on the psychrometric chart. You will draw that line, and that line is like your datum line that you're going to work off of, because you're going to project from point 2 to the saturation line. Don't, whatever you do in the exam, go and draw that line and then think you're going to work off of that line over there, where state point 2 is actually lower or even above that line, because then it's going to be wrong. You draw that line as a means to obtain a parallel line next to it, going from state point 2 to the saturation point. So from state point 2 to the saturation line, and you determine you read off your apparatus dew point from there. So you can only pick up your apparatus dew point when you project from state point 2 to the saturation line. Okay, don't get it wrong. I use the compass just because it's an easy way of making sure that I can get that thing as close to parallel as possible.